Okay, for our last section of Chapter 10, 10.7, we're going to be solving now quadratic inequalities. We have spent a lot of time throughout Chapter 10 solving quadratic equations. Now it's time to take a look at how we're going to solve inequalities that are of a quadratic nature. And what I've listed out here are 5 little steps that we're going to follow. And step 1, we're actually going to treat the inequality like an equation. Okay, we're going to temporarily forget that it's an inequality. We're going to treat it like an equation, and we're going to solve for x. And you could use whatever method that you want. Once again, if it's factorable, you could solve it by factoring. If you recognize maybe where the square root method works, you can use the square root method. Or if all else fails, if quadratic formula is your favorite, you can use the quadratic formula to also solve for x. And we're going to refer to those x values as the critical numbers. After step 1, after you have solved for x, the critical numbers, then what you're going to do in step 2 is you're going to put those critical numbers, those values of x, on a number line. And then you're going to look at the inequality symbol to determine whether or not you're going to have open or closed circles on those critical numbers. Remember, if it's less than or greater than, that means you're going to use an open circle on the critical numbers. If it's less than or equal to, greater than or equal to, then you're going to have a closed circle, a dot, on those critical numbers. Then we're going to pick values of x that fall to the left, to the right, and in between the critical numbers. And then you're going to test those numbers into the inequality, and you're going to shade where there is a true statement left. Now, let's see how we're going to use these steps to solving quadratic inequalities with some examples. Let's start off with x squared minus 2x minus 3 is in fact less than 0. So now, first thing that we want to do in step 1 is we want to treat this like an equation. So let's solve this equation for the critical numbers. Now remember, we can't use the square root method, and I'm not going to use the formula because I recognize this as being factorable, so let me factor it down. Factors of x squared, x and x. We're talking about different signs here, and the factors of negative 3, that would have to be a negative 3 and a positive 1, in which case now x equals negative 1 and x equals 3. Those are the critical numbers. So now step 2, we want to put those critical numbers on a number line. So let me draw a number line, and let me put those critical numbers on my number line. Well, negative 3 would go first. I'm sorry, negative 1 would go first, and then 3. Now we're up to step 3. We're going to look at the inequality symbol to determine open or closed circles. Okay, well, according to the inequality symbol, it's a less than statement, so I need open circles on those critical numbers. And what we have formed here are 3 regions. We're looking at all of the numbers to the left of negative 1, all the numbers in between negative 1 and 3, and all the numbers greater than 3. And what we're going to do in step 4 is we want to test out the values. We could pick any number in region 1, I could pick any number in region 2, and I could pick any number in region 3. Doesn't make a difference. Let's say in region 1 I pick a negative 5. Let's say in region 2 I pick the number 1. And let's say in region 3 I pick the number 6. And I want to take those numbers, negative 5, 1, and 6, and I'm going to plug them into the original inequality and see if it makes a statement that is either true or false. If the number that I picked is true, that means we would shade that region. If the number that I picked is false, that means we would not shade that region. So let's take a look. As far as region 1 is concerned, I picked the number negative 5. So I'm going to take negative 5 and plug it into the original inequality. So I would have a negative 5 squared minus 2 times negative 5 minus 3, is that less than 0? Let's see if that's true or false. Well, when we simplify the left side, that would give us 25 plus 10 minus 3. And let's see what that would give us. 25 plus 10, that would be 35 minus 3, or 32. Now, is 32 less than 0? That's false. And that means since negative 5 produced a false statement, that means any other number that you were to pick in region 1 would also produce a false statement. And if it's false, that means you don't shade that region. Okay. Let's try now region 2. In region 2, I picked the number 1. Let's plug in 1 back into the original inequality. That would give us 1 squared minus 2 times 1 minus 3. Is that less than 0? Well, let's take a look. 1 squared would be 1. Negative 2 minus 1 would be a minus 2 minus 3. Is that less than 0? 1 minus 2 minus 3 would give you a negative 4. Is negative 4 less than 0? That's true. And since 1 made a true statement when we plugged it into the original inequality, that means you are going to shade in that region. So not only would 1 work, but any other number in between negative 1 and 3 would also work. If you picked 0, that would produce a true statement. If I picked the number 2, that would produce a true statement. I am not limited to just the whole numbers. I could have picked 1.5. I could have picked 2 2/3. I could have picked a negative 1/2. And all of those numbers would have produced a true statement because all of those numbers come from region 2. Well, let's try out region 3 now. We have to test the value in region 3 that we chose, and that happened to be the number 6. So let's plug in 6 and let's see what happens. So now we have 6 squared minus 2 times 6 minus 3. Is that less than 0 according to the original inequality? Well, 6 squared is 36 minus 12 minus 3. Is that less than 0? Well, 36 minus 12 would be 24. 24 minus 3 would be 21. Now, is 21 less than 0? Well, no, that's false. And once again, since that produced a false statement, that means that we don't shade on the number line. So let's see what we have here in terms of our number line, and that will give us the solution to the inequality. Well, according to the number line, if we were to use that interval notation, now we're going from negative 1 to 3. And we have to remember to put parentheses around the critical numbers because we are not including negative 1 or 3 as our solution. So that would be the solution to this quadratic inequality. Let's try another one. Let's say we have x squared plus 11x plus 28. And that's now greater than or equal to 0. We want to solve for x. Well, remember, step 1 tells us to treat this like an equation of x squared plus 11x plus 28 equals 0. We want to solve for x, the critical numbers. So this is factorable. Once again, x and x. Same sign, both positive. And factors of 28 that add up to a positive 11 would have to be 7 and 4. Solving, of course, for x, we get x equals negative 7 and x equals a negative 4. So those are the critical numbers. Now, once again, we have to take those critical numbers and we are going to put them on the number line. here's negative 7, and here's negative 4. And then we have to look at the inequality symbol. The inequality symbol will tell us what we're going to put on those critical numbers. And because it's greater than or equal to, that means we have to have a closed circle. We're going to shade in the critical numbers of negative 7 as well as the negative 4, because they are actually part of the solution. And now once again, I have formed three regions. The region of numbers to the left of negative 7, the region of numbers in between negative 7 and 4, as well as the region of numbers to the right of negative 4. And we want to, once again, pick some numbers, any numbers that fall within this region. So let's say for the region 1, I pick the number negative 8. In region 2, I need a number, any number that I want. Let's say I was to pick a negative 6. And then I need a number in region 3, any number that I want. I'm going to pick 0. And now once again, what we want to do is we want to take negative 8, negative 6, and 0, or any number that you picked as well. And we're going to take those values and we're going to test them into the original inequality and see if we produce a true statement. Let's start first of all with the negative 8. So I'm going to take negative 8 squared plus 11 times negative 8 plus 28. We want to know, is that greater than or equal to 0? Well, negative 8 squared is 64. 11 times the negative 8 is a minus 88 plus 28. We want to know, is that greater than or equal to 0? Well, if we combine the terms on the left side, we get 4, greater than or equal to 0. And is 4 greater than or equal to 0? That's true, which means we have to shade that region. Because negative 8 worked, I guaranteed if you picked any other number in region 1, it would also work. Let's try now the negative 6, because that's a number that happens in region 2. And so we would take negative 6 squared plus 11 times the negative 6 plus 28. Is that greater than or equal to 0? Well, let's simplify what we can. Negative 6 squared is 36. Negative 6 times 11 would give us of course, negative 66 plus 28. Is that greater than or equal to 0? Well, if we do 36 minus 66 plus the 28, we get negative 2. And is negative 2 greater than or equal to 0 according to the original inequality? No, that is false. And if it produces a false statement, that means that you do not shade that particular region. Well, we have one more region to test out. We needed a number in the third region, a number that falls to the right of negative 4. And remember, I picked the number 0. So now we're going to have 0 squared plus 11 times 0 plus 28. Is that greater than or equal to 0? Well, 0 squared is 0. 11 times 0 is 0 plus 28. Is that greater than or equal to 0? Well, when we simplify the left side, we get 28 is greater than or equal to 0. And once again, that is true. And since it is true, once again, we have to shade that third region. Now let's look closely at the number line and see how we could represent our final solution using the interval notation. Well, remember, with the interval notation, we're going from a negative infinity up to the critical number of negative 7, which we have to include with a bracket, or then we have the critical number negative 4, which we will include, and the solution is going towards a positive infinity. Recall with the interval notation, whenever we use the infinity symbol, whether it be negative or positive, we always surround it with the parenthesis. as well as when the critical number is included when it's a dot or a closed circle, we have to use the bracket. Let's take a look at another one. Little bit different. Same idea. Let's say x squared minus 3 is going to be greater than 0. Once again, we want to start with step 1 and find the critical numbers. Well, here this is not factorable, and I'm not going to use the quadratic formula, because if I take a look at this equation of x squared minus 3 equals 0, I recognize that I could use the square root method, because I have the squared quantity and the numerical quantity. Excuse me. So I will add the 3 over. X squared equals the positive 3. And then I have to go and take the square root of both sides. And that would give me x equals to plus minus the square root of 3. Those are, once again, the critical numbers. So I have to go to my number line, and I'm going to put the critical numbers of the negative square root of 3 as well as the positive square root of 3 on the number line. And once again, we have formed our 3 regions on the number line. And so we need to pick some numbers. Numbers that fall to the left of the negative square root of 3. Numbers that fall in between the 2 critical numbers. And then I need a number that falls to the right of the square root of 3. Well, if the square root of 3 is approximately 1.7, I need a number that falls to the left of negative 1.7. I'll pick negative 2. I need a number in between negative 1.7 and positive 1.7. I'll pick, let's say, 0. And then finally, I need a number that falls to the right of approximately 1.7. I'll pick 5. And let's see if those numbers work. Let's start with negative 2. Negative 2 squared minus 3. Is that greater than 0? Oops, I forgot to determine whether or not we have open or closed circles. Well, the fact that it's just greater than, open circles. Now let's go and test for the shading. When we simplify, we get 4 minus 3. Is 4 minus 3 greater than 0? Well, sure enough it is, because that's 1, which is greater than 0. That's true. And if it produces a true statement, we would shade. Let's try now 0 in region 2. 0 squared minus 3. Is that greater than 0? Well, 0 squared is 0 minus 3. And since 0 minus 3 is negative 3, is negative 3 greater than 0? No, that's false, which means we don't shade. Region 2. Finally, now let's test out region 3. We chose the number 5. 5 squared minus 3, is that greater than 0? Well, 5 squared is 25 minus 3. 25 minus 5 is 22. And is 22 greater than 0? I believe so. And since that produced a true statement, we would have to shade region 3. So our answer, once again using the interval notation, would be going from negative infinity to negative square root of 3, parenthesis, or parenthesis, square root of 3, comma, infinity with a parenthesis. The last thing that I need to show you in this section of chapter 10.7 are, of course, the special cases. We always have to have special cases. Let's take a look at, I'm going to give you 2 problems that are similar, and the only thing that's going to be different is the inequality symbol. Let's say, for example, we have x plus 4 squared is greater than a negative 5. versus, let's say, we have x plus 4 squared is less than a negative 5. So here we have two special cases. These two inequalities look very similar, okay? On the left side, they have the same algebraic expression. On the right side, they have the same negative number, negative 5. The only thing that's different in these two special cases is the inequality symbol. One says greater than, the other says less than. But let's think about the left side for a moment, okay, since the left side is the same. If you were to plug in random numbers, any number that you could think of for x, and then add 4 to it, and then squaring that number, what kind of number would you get? Well, you would always get a positive number. For example, if I plugged in, let's say, the number 2 for x, 2 plus 4 would give you 6. And if you plugged in 6 and squared it, you'd get 36, a positive 36. Let's say we plugged in another negative number. Let's plug in a negative 7 for x. Negative 7 for x plus 4 would give you a negative 3. But when you square that negative 3, you're going to get 9, and that's a positive 9. So regardless of what number you substitute in for x, when you add 4 to it and then square it, the left side will always be a positive number, regardless. Okay, you will always get a positive number on the left side because no matter what, you are squaring that number. And whether you square a number that's positive or negative, it'll always be positive in the end. So that positive number, will that positive number be greater than negative 5? Yes, always. That is always going to be true. And since it will always be true, what we have to say is x is the set of all reals. Remember, the interval notation for that is a negative infinity to infinity. So that would be your solution for the first one. The second special case, once again now x plus 4 quantity squared, is now less than the negative 5. Well, since the left side will always be a positive number, will a positive number ever be less than any negative number? Okay, of course that's false. That is not true. Okay, and since this will always be false, we know the solution would then have to be actually no solution. So those are the two special cases. Special cases always involve either all real solutions or no solutions. Okay, so you have to look carefully at what it's going to be either greater than or less than the negative quantity. Since the left side will always be positive, a positive number is always greater than any negative number. That's when you write all real solution, negative infinity to infinity. If we have a positive quantity less than a negative number, that is always false, and that's why we write no solution. That concludes the lesson for section 10.7, as well as that also concludes chapter 10. Okay. Of course, there is homework that goes along with this section. Give it a try, and if you have any questions, please feel free to email me any concerns that you may have. Hope you are well. Talk again soon.